So next, we're going to look at the inverse cosine function, cosine inverse or arc cosine. And I'll say one more thing for the construction that we're working from. Very rarely are we going to put these things in terms of thetas, because we like to talk about theta specifically as an angle measurement. And very importantly, we generally don't evaluate the inverse trig functions at angles, because the question that an inverse trig function asks isn't what does this angle do, it's where does this angle come from. But anyway, for cosine, we have much the same construction, much the same central issue, as cosine has basically the same periodicity as sine. That is, it's very much not one-to-one, so we're going to restrict it now to the domain 0 to pi instead of negative pi halves to pi halves. I think this is so that we have the cleanest picture that goes the range from negative 1 to 1, but again, the choice is somewhat arbitrary. Main thing is, once we have that restricted domain, we can get our inverse cosine function, where for this, we have the same flavor of table, the same type of idea in terms of being able to find inverse values using known values of cosine. It's just now our range is from 0 to pi instead of like before. So if we want to take a quick example, and find inverse cosine of 1/2, we can follow the same sort of logic as before, that cosine inverse of 1/2 is the same as saying cosine inverse of 1/2 equals theta, is the same as saying cosine of theta equals 1/2, which you can get by essentially evaluating cosine on both sides. That's the defining relationship of our inverse, where on the interval from 0 to pi, cosine only ends up hitting 1/2 at a single point. That is, theta must be pi over 3 by design for our inverse function. And the last thing we're going to look at for this section, the last thing we're really going to look at for this chapter, is a bit on the inverse tangent function.